Hi guys. In the last problems we were finding pHs, and I call what we're doing this time what are called backward calculations. I'm going to write down the formulas we have. We've got pH equals the negative log of the concentration of hydronium. We have pOH equals the negative log of the concentration of OH. We have pH plus pOH equals 14, and again our KW formula, which is 1e to the negative 14, equals concentration of H times the concentration of OH. And again, reminder, H is hydronium, OH is hydroxide. Okay, so let's talk a little bit about why these are backwards calculations. So the example that we're going to give you today is something like this. We're going to find the concentration of H plus when the pH equals a certain value. So let's say 4.50. Now these remind me a lot of the problems from last chapter, the solutions chapter, where say in the parts per million or percent by mass or volume problem, we actually gave you the percent by mass, percent by volume, or parts per million. And it's like you had the answer to the problem and then had to work backwards. So it's kind of what these are. You're given pH, they want H. It's pretty obvious here what formula we're going to use. It's going to be this one. But instead of finding the pH, we're given the pH. So we're given the answer. So here's my formula. Again, it's always good practice to write that down first. And now I'm going to plug this answer, since they're giving me pH, into the end there. So I get 4.50 equals the negative log of H. Now my job is to find H. So I have to get rid of two things, the negative and the log. Now we can't divide by a negative log. That would make our life super easy, but it's not possible. So first thing we're going to do is get rid of a negative by just multiplying both sides by -1. So what that's going to give me is negative 4.50 equals, and then -1 times -1 is just 1, the log of H plus. All right, to get rid of a log, by the way, you don't have to know anything about a log to do this. I'm going to teach you enough to just be able to calculate it. To get rid of a log, we take something that sounds kind of funny. It's called an anti-log, but that's not a button on your calculator. The button on your calculator that you all are going to see is going to be this button right here. It's called the 10x button. That's the anti-log. That's how you get rid of a log. So to get rid of the log, we take the 10 to the x. So what we do on each side is we take the 10x, and you don't have to plug anything in over here. It just disappears. But this on the left-hand side, you do have to plug in. That's what I plug into my calculator, 10 to the x of negative 4.50. So I go back to my calculator, it's second log, there's my 10, and don't forget the negative, that's really important, negative 4.50, and I get this number, and normally it's going to be in scientific notation. Now if you're using your cell phone as a calculator, it's probably going to have a decimal point with the zeros in front of it. It's going to be in regular notation. 3.1 or 3.2 e to the negative fifth. And we're going to round these just to two sig figs just to make things simple for ourselves. So 3.2 times 10 to the negative fifth. Since it's a concentration, we're going to give that answer as molarity. Okay, so let's go ahead and do another one. And by the way, again, it's always a good idea if you need to go ahead and pause these videos or slow them down or listen to me do it once and then go through it again. All of that is helpful when you're doing distance learning like this. Let's do another one that's similar. So find the concentration of OH when pOH equals, let's say, 2.75. Okay, so first of all, we are given pOH. They want OH. I'm hoping it's obvious that we're going to use this second formula. And again, always good practice to write down that formula before you begin plugging numbers in. And again, just like the last time, they're giving me the answer. They're giving me this value for over here. So let's substitute that in. 2.75 equals the negative log of OH. And let's remember our two steps. We have two steps to do the math here. First step, multiply by -1. So times -1 times -1. And by the way, what's nice about this chapter is it's open notes, so you can look over how to do these problems while you're doing any quizzes on this. All right, there we go. So that's my first step, multiply by -1. My second step is to get rid of the log, but I can't divide by it. I do the anti-log, which is just that 10x button. So again, I don't have to type anything in over on the right side. That just cancels. And this is what I type into my calculator. Now this 10x part, the x is going to be the button on your calculator, but it's not actually going to show up on the screen. It's just going to be 10 to the negative 2.75 power. So we're going to go back and again find that button. 10, oops, I did the wrong one, that's E. Make sure if you're using your calculator, you're using base 10 log, which is the LOG button. So 10 to the negative, and now I've forgotten the number. Let me go back quick, 2.75. All right, so the negative 2.75, and I get for an answer, notice it's not in scientific notation this time, and that's okay, 0.0018. So 0.0018 m. And that's going to be your answer for the concentration of OH. All right, so those are what I call the more basic calculations that are backwards, but just like we had a little bit of a trickier calculation for pH and POH, there's a little bit of a trickier one here as well. So let's do one final example. We're going to find the concentration of H+, but instead of being given pH, I'm going to be given POH. Let's do 9.37. Okay, so let's look at what's given. We are given the POH and we want to find H. So I always like to look at what's given and see what we can find using our formulas over here. Now if I'm given POH, I could find OH, and I guess I could eventually get to H from that, but there's an easier way. If I am given POH, I can use this formula to find pH first, can't I? So remember, to get back and forth from pH to POH, you basically just subtract from 14. So that's going to be my first step. So first step is to find pH using the formula pH plus POH equals 14. So here's how we use that formula, okay? pH plus, and I'm going to substitute in that value, 9.37 equals 14. I simply subtract 9.37 from each side. So I take 14 minus 9.37, and a lot of you guys can do this in your head. We get 4.63. All right, so I know pH is 4.63. Now that I know pH, I'm going to do what I did on the first two problems and find the concentration of H. Now keep in mind you can do a very similar problem if you're given pH and need to find concentration of OH. It's essentially the same thing. All right, so let's find H+. So we're given pH. We're going to do the exact same thing we did above. So I'm going to use the pH formula and substitute in. And again, just like in the first two examples, I know the answer. So 4.63 equals the negative log of H+. Now hopefully you're starting to figure out a shortcut here. Does it make sense all the time? We just move that over. So negative 4.63 equals the log of H+. And again, I just take the anti-log. So 10 to the negative 4.63 is going to give me the answer. So let's go back to my calculator. 10 to the negative 4.63. So 10 negative 4.63. 2.3 e to the negative fifth. So 2.3 times 10 to the negative fifth, m for molarity. All right, you are now set to do the other calculation problems in part 2 of your packet. Good luck.